Okay, let's start at number 19. LCF number 4, number 19. I love this question. Okay, listen. I love questions that make you think and we get to talk about before you get to an AP. Okay? Because it comes back to a forever card. If they gave you a second derivative and they're asking relative max, there is a test for that. Second derivative test for relative extrema. What does it say? I need a critical number. F prime equals 0 or DNE. I need a critical number. F prime equals 0 or DNE. And I need to know the sign of the second derivative. Sign chart would be for concavity. Second derivative sign chart. Second derivative test just says plug in. Is it concave up with a horizontal? Min. Is it concave down with a horizontal? Max. Is it, maybe the test fails. Go back to the first derivative test. Okay, so let's see what we have. Which of the following could be the x-coordinate of the relative max of f of x? Could be the relative max. So, could be, doesn't say it has to be, just it could be. Why? Because I have no idea the critical numbers until I anti-derive. I have no idea the critical numbers. And that's a key part of the test. If I knew the critical numbers, then I could say for sure this one is a relative max. So let's think about this. If you plug in 0, isn't the whole thing going to be 0? Undefined? ln of 0 doesn't exist. Well, then there's no concavity. I have no clue. Okay, if I plug in 1, that would exist, that would exist, that would, wait, okay. So if you plug in 1, what's the second derivative sign? Who figured it out? F double prime of 1 is it negative?
Yeah, because,
That's going to be a positive, that's going to be a positive. No, it's a positive, isn't it?
Wait, ln of 1 is
ln of 1 is 0, but there's still a 1. So 1 times 4 is positive, right? Okay. What's f double prime of 4? Positive, positive, positive. What's f double prime of 6? Negative, positive, that's a negative. And then I have f double prime of 5. That's 0. That's a pip. No way.
It all lines up.
Positive, positive, concave up, concave down. If it was a horizontal tangent, it would be a min, so that's not going to work. Maybe. If it's a critical number, maybe. Maybe, could be done. Done. But wait, what did I do to start this problem? I thought of what did I have? What were they asking? Is there a card? And I used it. Right? Why is it a could be and not a must? I don't know if it's a critical number. Are we okay? Okay, any other multiple choice questions? Odds? Well, yeah, I start with multiple choice. Multiple choice questions, going once, going twice. Number 5. Okay, this will be our last one. The rest of you guys didn't have one ready and you were able to already work on it. So if you have any other questions, I'll be here during lunch or after school unless I'm looking at the greatest champion, whatever it's called, gym competition thing. Okay, so number 5. And if I'm in there, just come sit next to me and be like, so, calculus. And I'll be like, yep. And I'll be watching, but I'll be listening. Okay, so what is the x-coordinate of the point where? Has a tangent line. I have an original. Isn't LCF number 4 all about there are 3 different camps of quantities? Originals, first derivatives, second derivatives? I have an original. Tangent line. Ooh, slope is a derivative. Parallel, same slope. That's pre-cal. That's algebra 2. That's algebra 1. Same slope. What is your slope? Get y by itself, yeah? Negative then positive. -2, right? Okay. But anyway, this is the tangent line. Tangent line, slope of a tangent line is the derivative. So m equals 3 equals y prime of somebody. I don't know who. Who is that point of tangency? Wait a minute. Y prime, couldn't I find that? Y prime is equal to 4x cubed minus 6x squared. Ooh, couldn't I plug that in? Ooh, couldn't I see 3 is equal to 4x cubed minus 6x squared? When? I don't know, at the point of tangency. Hey, they're asking me for the x at the point of tangency. Okay, solve. Some of you are like, oh, that's gross. Exactly. What types of answers do you have?
Nasty one.
Decimals. What's next to the 5? A GC. What does that mean? Use your calculator. Pause. This is an important calculator skill that you're supposed to be able to do that we have done this year, but some of you are like, ah! So let's make sure that you can do it for tomorrow, because I promise it'll come in handy at least once or twice or 10 times. Probably not 10 times. How can you solve for the zeros? Graph it and look for the intercepts. Now what if I had left it like this? I could have. How could I have found where these two are equal? Y2 or Y1. The other one, so I have two different Y's, and what would you be finding? The intersections. Sometimes intersections can happen in weird places to where you would have to make that window all over the place. It could happen up in the thousands or the hundreds or 0.00. Where's the zero always going to be? On the x-axis. Doesn't mean that the x's might not be weird, but the y, I just need y equals 0, little above, little below my window. So sometimes intersections can be weird, but you can always graph, and there will be an intersection where, move everything to one side, this is a 0. So double check real fast. Ooh, polar mode. BC, sorry. Polar comes back in BC, not in AB. I'm not going to type this in. You guys don't need me to do that. But this one could be, right now, x squared equals this mess. And if we went to our graph, if your graph is ever weird, you can always hit the on button. If your graphing calculator is ever thinking, you're like, ugh, on will break the code. We'll say, stop doing what you're doing. It's like, you can make it do something else. Like, you can always go zoom standard, reset it. Reset it, zoom standard. Well, enter pauses it. On says stop. Enter says wait, and it's like, but you have to get it to keep going. On says just stop, just cancel. It's like, okay. Well, sometimes if you plug something in weird, it could be thinking for a long time, and you're like, la, la. I mean, you could take out the batteries, but anyway, some of you had the little screwy things. Okay, always do zoom standard. Then you could zoom in, you could zoom out, you could mess with your window. So guys, right now, I could use the where's the intersect feature? Second, trace. Intersect is number 5, I think, right? How do you answer these questions? If it's on 1, enter. Well, you might have 3 or 4. So make sure that you're choosing the right 2. Hit enter, and then when it says guess, it might intersect in more than one place. You're going to the intersection and saying, please go find him for me. Now, if you were going to do the 0 feature, you wouldn't have put this in 2 different places. Instead, you would have gone ahead and, hold on, there's a trick, but what is it? No, there's a trick to skip to the end of a line of code. Why can't I remember? I haven't used it enough. Is it second over? Yeah, you can do second over to get to the end of any line of code. Or second back to get to the beginning of any line of code. I just learned that this year. Pretty cool. Anyway, you could do the minus x squared. You're moving it to the other side. And then when you do graph, now you'd be looking for the 0. How do you find a 0? How do you answer those questions in your calculator? You have to find the 0 that you want. Make sure you're a little bit before. It could be above, it could be below. Just a little bit to the left. Hit enter. Make sure it's obviously to the left. And then go obviously to the right, like not even close, obviously to the right. And then just say, the guess is in case there's multiple ones in between. Dun, 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 dun. This isn't for this problem, but you guys get the idea how to use your calculator. Cool. So solve. All right, multiple, nope. Time is done for that. FRQs. FRQ 1, any questions? How many FRQs did you have that were odd? Just 1. Okay. Tyler, you were asking about this being an FRQ. Very frequently, something like this is an FRQ. But more and more recently, what I've been seeing is that they're doing something like, hey, here's a graph of g, and g is equal to the integral from a to x of f of t dt, and they ask you about f. It's very, Yeah, but it's very similar because if they give you this, which is called the accumulator function, we kind of talked about it, then I should say this way. To think about f, you're going to think about areas. Why? Because you would have to look at his integrals. So you'd have to look at areas to think about f. To think about f prime, to find f prime. Oh, wait. Sorry. This is not what they would give you. Pause. This is f. I apologize. Okay. To think about g. I apologize. They'd be asking about g in all of these. To think about g, you'd have to think about the areas under this guy. To think about g prime, well, to find prime, what do you have to do? Take the derivative. What's the derivative of an integral? Just plug them in. Boop, boop. F of u times, well, u prime is just 1, so it would be f of x. You would just look at the y value of this guy. And then to think about g double prime, concavity, points of inflection, etc., you would look at his prime, g prime's prime, his prime, slopes. So I apologize that I'm changing the question, but I'm saying, Tyler, this is more and more what I've been seeing, which is still looking at the graph of a derivative. Does that make sense? You just have to get there a little bit stranger. But I'm also saying these might not be the exact 4 questions they ask you, but they will be asking you to analyze the behavior. So here is a graph of a derivative. It's much more simple in the sense of f prime, talk about f. Okay, talk about f, talk about f, talk about f, talk about f. This is the graph of the derivative, thinking back to the original. They tell us that there are, well, I don't know, sorry, where was your question? You guys have already looked at it and graded. Where'd you get stuck? Okay, we're good?
Oh, I just have a quick question. On D, how would I justify? Because I said no, which is correct, but I said that it's not, that the graph is not twice differentiable because of the sharp point and graph.
Because to be twice differentiable, the second derivative must exist. And looking at this graph, how are you visualizing the second derivative? Slopes of the tangent lines. Good, slopes of the tangent lines. And you realize at 0.75, the slope from below will not agree with the slope from above. Therefore, the second derivative, the slope will not exist. The function can't be twice differentiable. As soon as you say the second derivative cannot exist and you say why it cannot exist, you don't even have to go into like the derivative is a limit and the limit is, just say, the slope from below will not equal the slope from above. You can say that this, no, that's easier. The slope from below, you could even, you could do a quick little limit as x approaches 0.75 from below of f double prime. You could do that if it does not equal the limit from above. Or you could just state and say, hey, since there is a sharp point at 0.75, the slope at 0.75, hence the second derivative will not exist. No. Charlotte, did you have a question on that?
No.
Okay. All right, let's switch. Practice exam. That's the point, and we have about 25 minutes. Huh?
Question about that. Wouldn't the graph, isn't it still, there's a graph for a second derivative, but it just has a hole at, I know
Right.
it would be like here and here, because they're
Right.
different slopes, but,
So twice differentiable, think of it this way. A derivative is a limit. So it is possible for one of these graphs to have values that are everywhere. Because even here, even though it's broken, you could have a filled-in point normally. But for derivatives, derivatives are limits. And if the limit does not agree, the derivative will not exist, which means not only are you going to have a break, but also both of those need to be empty. So therefore, at that one point, the derivative does not exist if the second derivative does not exist. And if the second derivative does not exist anywhere, you cannot say that the function is twice differentiable everywhere. Does that make sense? So you're not saying it's not anywhere. What you're saying is, oh, it fails once, so I cannot say twice differentiable, which means the second derivative exists for all values of x. Yeah. Okay, so practice exam. Multiple choice. Yeah. We were on like 25 to 30 yesterday. Is that right? Except there aren't really very many questions 25 to 30, are there? Or 26 to 30? 28, okay. Then we'll transition to the graphing calculator multiple choice. So let g be a twice differentiable. The second derivative exists everywhere. Function with, guys, you have to attach it. G prime's sign talks about either positive slopes or you could say g is increasing, right? It means the same thing. G prime positive, g is increasing, or positive slopes. If g double prime is positive, g is concave up. Careful, never say it whenever you're writing the answer, because your it could refer to what you don't mean for it to refer to. Always state who you're talking about. Such that g of 4, clues, of all the following, which is a possible value of g of 6. You guys have seen multiple questions where they give you little tables. So if you want, you could think about it this way. You have 4, you have 5, and they're saying 6. You know 12, you know 18. Question. What can I right away? Almost everyone would be like, there's no way that this could be A or B. Because A or B, just right away. I need it to increase. I need the y's to increase. So it can't stay the same and it can't go down. So right away, those ones are out. Okay. Nice thing is, I'll just leave it there. C and E. Now we have to think about, ready? How much did this increase by?
6.
If I have the increasing portion of a concave up graph, concave up can be concave up decreasing or concave up increasing. What's happening to the changes of y of my tangent lines on the decreasing portion? The changes of y are going down. What's happening to the changes of y on the increasing portion? They're going up. So I need the changes of y for an increasing portion of a concave up graph to be going up. So it cannot go up by anything less than or equal to 6. So 18 to 21 is only going up 3. 18 to 24 is only going up 6. The only possible one is 27. It could have been anything above 18 plus 6 is 24. It could have been anything above 24. Okay. Let's go to graphing calculator multiple choice. Oh, okay. 27. That's okay. Ooh, yes. Inverse derivatives. Thank you, Sean. We have a formula for, I'm going quick because you guys were already able to look at the problem and look at the answer key. G prime of 2 is, who is G? F inverse. Is F inverse prime of 2. We have a formula for that. And the formula is 1 over F prime of F inverse of 2. So pause. Couldn't we say if F inverse is G, couldn't we say 1 over F prime of G of 2? Now, here's a quick heads up. Usually, lately in the AP, they wouldn't just give you this one clue. They would give you a few clues, and only one is the right one to use. They wouldn't just give you G of 2, they'd give you G of 1, they'd give you a few different clues. You'd have to choose the right one. This is the only clue I need. Now pause. Who is G of 2? 1. So I need to go ahead and plug in 1 over F prime of 1, which is 1 over, F prime, 3x squared plus 1. 3, 1 squared, 1. All right, graphing calculator multiple choice. Guys, it's on the video. If it's ever too fast, you can go check it out. So we're on the numbers. P.S. The graphing calculator multiple choice always skips to a new number. Why? If you've gotten off, now everybody gets to now be on again. Does that make sense?
Wait, that's in the regular too?
Yeah.
And that's
This is an actual AP. Okay, number 76. They just always do it. It might have something to do with their sheet too, because their sheet's obviously different than my sheet. My Scantron's but theirs is different, but that's okay. 76 to, let's just go over graphing calculator. Anybody have anything like in the 70s or 80s? Start somewhere.
Let's start at
80? Okay. Number 80. Okay. As soon as you see, now this is just us trying to get a feel for a question, right? I see continuous, I see differentiable, and I see there exists. I should be thinking theorems. Okay. When I look over here, I should be thinking maybe IVT. Why? That's an original value. Maybe MVT. Why? That's a prime. Now rolls, MVT, MVT rolls. Remember, rolls is just a special MVT. This one, ooh, IVT. This one, ooh, MVT. Not rolls, because that's a number, not a 0. And then this one, I don't know, IVT, EVT? It's not quite just a normal, something. Okay, this is all like little question marks for my brain to be thinking. You guys see why? Okay. So I see my 2 clues. And I see continuous differentiable, which means all the theorems apply. Okay. My 2 clues. My y's go between -5 and 4, which means my y's are going to have to hit anywhere between -2 and 1, everything in between. Which of the following could be, oh, nasty? Do you think that's why? Does that make sense? It might make all the difference, because there must be a 0. Like, there's a lot that are going to be true. There you go. Oh, sorry, why B? It must be B because f of A doesn't equal f of B. Why is E true? Okay, E, this is the weirdest wording. There must be a C in between such that, okay, here's what this is saying. Such that there must be a place where the y of that place is higher than all the others. There must be an absolute max. That's all it's saying. There is a place where that y is higher than the rest. Absolute max. Oh, yeah, EVT guarantees continuous on a closed. Hold on. Oh, closed interval. Yeah, that's EVT. Okay, another one. Pause. So for the test, whenever you take it tomorrow or Monday, read the question carefully. If there's a true, you circle it. If there's a false, you circle it. You underline it. Make sure your brain sees it. Sorry, Austin, go ahead. 77. Okay, I'm only going to take 2 more multiple choice. So if anybody has a question, you can fight for it. 84 and?
every single one wrong. Let's say.
Does anybody else have one? Because Nathan, odds are. Sean, do you have one?
No, I'm good.
Okay. Anybody else have one? 77, 84. Okay, Nathan, just pick one. Sure. Okay, so 77, 84, then 87. Let's go to FRQs if you guys want to be looking there. Here we go. The regions A, B, and C. Areas. Areas under. There's an integral. If the area of each region is 2, what's 2? This guy's 2? This guy's 2? This guy's 2? What is the value of, now, something to note. If you're going from -3 to 3, isn't that the normal direction? Oh, okay, so that's the normal direction. If it was backwards, I'd have to make all the signs opposite. But can't I say if I'm going the normal direction, he's a negative, he's a positive, he's a negative? So I just do -2 plus 2 minus 2. Now hold on. What's different? Plus 1. Check it. You can split up integrals, can't you?
Yeah.
Can't you say this is equal to -2? And can't you find this one all on your very own? But you're not supposed to flip. It shows the bounds -3 to 3. Oh, if it was flipped, everything would be opposite. So you could solve. You could either just solve and keep it, or you could flip at the very beginning with a big old negative outside. Yeah. Okay, then 84. Then we're going to 87 if you guys want to look ahead. Love it. Concept-y. Guys. That's okay, just one quick second. Hold on. In any word problem tomorrow, they could give you anything they want. Pizzas, potatoes, bananas, snow, gravel. What's something weird that some people don't even know what it is? Sure. Well, I mean, that's, okay, fine. Nuclear decay. They could give you anything. Find the math. What's original? What's rate or derivative? What's rate of rate or second derivative? Okay. Pizza, fine, whatever. Temperature, okay, how hot it is, whatever. Whatever. Okay, it's placed, taken out of the oven at 0 minutes. Temperature is changing at a rate. My rate, or my temperature prime, is equal to negative 110 e to the negative 0.4 t. My rate, or my temperature prime, that's the rate of temperature, temperature prime. To the nearest degree, what is the temperature at? Colored pen, integration as net change. They want the final temperature. Sorry, I just wrote over it. What is it? 5. Final temperature equals, they better tell me something. They did. They told me it was 350 degrees when taken out because it heated up to that. Integral. What do? Plug it in your calculator. Wait. This is 350 degrees. Plug it in your calculator self. No, negative. So negative goes in, and it will be a minus because of the negative.
They just did it a different way. They put in an absolute value and they thought subtraction.
Oh, they were thinking absolute value, and they were thinking minus because they're like, oh, it's cooling down this amount. So they made it the absolute value, like speed kind of. They just said, how fast? And cooling down. But it happens if you just plug in negative. It's okay. Oh, you thought it was negative. Yeah, that wouldn't work. Absolute value, it's okay. All right, 87. Then we're going to FRQs, guys. We're going to have to be very specific FRQs. 87. Ooh, a first derivative. Hey, LTF number 4. You've got to get your bearings on original, first derivative, second derivative, right? Okay. The first derivative is given by, what is the x-coordinate of the inflection point? Your calculator is such a champ if you know how to use it. Because your calculator, look, can take the derivative. Where is this guy? You could do it this way from the very beginning of the home screen. You could do it this way from the very beginning of the home screen. Did anybody know what number that was? 9? Thanks, Sarah. It's okay. It's even faster than me scrolling still. So you could do, pause. You could do ddx of, and you could type in that whole function, and you're such that, but what's the problem? You have lots to try because you can't plug in a such that. So wait. Can your calculator graph it? Why do we want to graph it? Because it's asking for possible inflection points. What are we looking for? Zeros and DNEs. Where could I see the zeros, x-intercepts, and DNEs, vertical asymptotes? On a graph. Does it give me any sort of, doesn't give me any sort of like region. So then in your graphing calculator, can you graph second trace a general, what's going on? Maybe I can't. Second trace is a graphing function. Hold on. Does your calculator actually do this? I'm about to be really impressed if it does. Sorry. You guys know alpha y equals make the nice pretty fraction, right? Okay. So then we have the square root of, I honestly did not know it did this, if it does. And if it does, my life is about to change. And all of my tests are going to have to change, and all of you guys using the graphing calculator is going to have to change. I don't think it can, but what this person is saying is that it can. Okay. Whew. Okay, I got really scared. What would you have to do by hand? Take the derivative. And what are you going to do after you take the derivative? Graph it. And what are you going to do when you graph it? Find the 0. How are you going to find the 0? Using the calculator.
Just plug the
No. Oh, plug the function in.
from the
Find its maximums or minimums. Yes, or its sharp points. Or its sharp points that are maximums or minimums. No. What are they saying? They're saying you don't need to find the second derivative. They're saying, hold on, remember, didn't we just deal with how to look at a graph of a first derivative and realize that the slopes of the first derivative are the second derivative, and the slopes will change at maximums and minimums of the first derivative? So you could find the second derivative, find the zeros, and maybe make a mistake in your differentiation. Or you could just graph the first derivative and say, maxes, mins, where are you? Okay. FRQs. B. Okay, FRQ. Tell me a number for us to jump and look.
4D.
Okay, number 4D.
Oh boy, yes.
Okay, number 4 was given a graph, right? Given a graph of who? F prime.
Yeah.
Yep.
Yeah. So there's going to be some integration.
Letter D, just check it. Letter D says find f of 3 and f of negative 4. Non-calculator problem, absolutely no function for that graph. Pause. If I'm given clues about a derivative needing to get to an original, how do I go from derivative back? Area, integrate. Okay. Now pause. Did they tell me a way or a place to start? Yes. They gave me an initial, and I'm finding 2 different finals. Integration as net change. Now, integration as net change says you can get to. Now, they showed, goofs, they showed fundamental theorem of calculus. I would go straight here, in a sense. I would have done, to get to the to get to negative 3, you can start at 0. To get to a final, you can start at an initial, but pause. You have to go from the initial to the final. Why is that weird? You're going backwards. Why is that weird? You have to flip the sign of what you see. So this would be the same thing as f of 0, which they gave you, minus the integral from negative 3 to 0 of f prime of t dt. This one's a little more straightforward because you can just say f of 4 is equal to f of 0 plus. Now hold on. I know, you can pack up. How do you find the area from negative 3 to 0? A triangle minus a triangle. Geometry. How do you do it from 0 to 4? A rectangle minus a semicircle. Guys, I'll be here during lunch. If I'm not coming to gym, bring your problem to me. Otherwise, I should be here period 7 unless something happens and after school. Sound good? All right. I can't be here too late today, though, because I have a lot to do for tomorrow. Bye, guys. See you later.